Okay, good morning, guys, or I guess good afternoon or evening whenever you're watching this. I hope you're doing okay. I hope you finished up everything from our linear relations unit. We are going to move on to our next unit now. So, the next unit that we're going to be working on has two parts. So, one of the parts has to do with square roots, and then one of the part has to do with surface area measurement. So we're going to work on the square roots part first for the first couple weeks, and then we'll work on the square roots part for the next couple weeks. So with the square roots, this first skill builder is just kind of reminding you what a square root is. On Monday, I got you guys to write out, your first 20 perfect squares. So that's going to be used as reference when you're estimating. So if you're there's two different things. If you're going into Essentials Math, you definitely should have out that sheet to help you. In Essentials Math, you're able to use a calculator, and the same with here. So if you're planning on going to the Introduction to Applied and Strict Calculus Math next year, that's the more difficult one. It's expected that you have your perfect squares memorized, and then you answer questions given that you already know the answers to those ones. So I would encourage you, if you're going into Introduction to Applied and Pre-Cal, maybe use the sheet for today, and then after that you start to have those memorized so that you're not using that as reference. So it's just going to help you that much more next year if you already know them. Okay, so just a reminder, we can relate square roots to area, and so the area of that square is considered the square. Okay, so and then the side length would be the example of what the square root was. So if you remember, the square root's asking the question, what number times itself gives me that number underneath the square root? And so you're thinking about, for example, if you had 25 as your square, what number times itself gives me 25? So that would be 5. Okay, so moving on to the first check. So here it's just taking that area model idea. So can you find the area? So remember that of a square, that's side times side. So here 7 squared would be 7 times 7, which is 49. So the area of the square would be 49 square units. So if I wanted to take the square root of 49, that's asking the question, what number times itself gives me 49? That would be the length of the side, which is 7. Okay, for the next one, I'm looking at finding the area, so that's going to be the side length squared. The side length is 4, so the area would be 16 square units. Okay, and then going to use the area to find the length. So working backwards, the square root of 16, so that's asking the question, what number times itself gives me 16? So that would be a 4. Okay, for the next one, we're looking at a side length of 8. So to get the area, instead of counting all the squares, we can think of this as 8 times 8, or 8 squared. So that's going to give me 64. So the area of this square would be 64 square units. There'd be 64 of them, right? We're taking the length times the width. So we're using the word square a lot, and that's when you visualize that it literally makes a square. If the length and width don't match, you make a rectangle instead. So you wouldn't be able to take the square root. So you can only take the square root when it is actually a square number. Okay, for the next one, we're taking the square root of 64. So asking ourselves what number times itself gives me 64. So that would be 8. The side length is 8. Okay, and the last one down here, 11 squared is going to give me 121 squares altogether, 11 times 11. So the area has 121 square units. Square root of 121. What's that side length? The answer would be 11. Okay, so with square roots, you can think of that relationship in an area model if that helps you to figure out what the answer would be. So basically here, the square of a number is the number multiplied by itself. So we know that from our exponents unit. So the square root is the exact opposite of that. So squares and square roots are called inverse functions. If you remember in our algebra unit, we remembered that adding and subtracting are opposites, and then multiplying and dividing were opposites. So in this unit, we can see that squaring, taking a number and multiplying it by itself, is the exact opposite of taking the square root, because that's asking what number times itself gives me that number. So squares and square roots are the exact opposites. So here, maybe do the check. You could pause the video and see if you can complete the check. So 4 squared, because 4 squared equals 16, the square root of 16 therefore would be 4. Because 12 squared equals 144, the square root of 144 then would be 12. So keep in note, it's not, the answer is not 12 times 12, or the answer is not 12 squared, because you have to think of the square root question as what number times itself gives me that number. So in the answer, you only end up with one number. Square root of 25 is 5, because 5 squared, which is 5 times 5, gives me 25. Square root of 100 is 10, since 10 times 10, or 10 squared, gives me 100. Those are inverse functions, and you even actually learned that last year when you worked on the Pythagorean theorem. At the end of the Pythagorean theorem, you have a squared number, c squared, and you have to remove that square. So if you remember what the last step of the Pythagorean theorem is, it's to take the square root of both sides. So you have practiced this last year, and you'll continue to practice it this year. Okay, so now we look at the concept of a perfect square. So there are only certain numbers that fall under this category. You have them on your list. Perfect square numbers can only basically be made if they're a product, so that's multiplying. So if they're the result of a multiplied question where you're multiplying two equal factors or two equal numbers. So for example, 25 is considered a perfect square number because I can make it by going 5 times 5. Okay, so I can make a 5 by 5 square, and it's got 25 units, or 25 squares. Okay, so 20 would not be a perfect square number, because if I try and make a square out of the factors of 20, I can do 4 times 5 to make a 20 square. I could do 2 and 10 to make 20, but there's no two numbers that I can multiply together that are equal that give me 20. So only certain numbers fall into this category, and you've got them listed on your paper. So memorizing them is what I need you to do. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. So these are the perfect square numbers, and so on. I'm going to run out of room, but I want you to go all the way up to 20 times 20. So if you think of all the numbers that fit between these numbers, like 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, all of those numbers are not perfect square numbers. So if I took the square root of a number that was in between one of these numbers, say the square root of 10, I wouldn't be able to figure out a number that times itself, it would give me 10. So what happens with those numbers are they work out to be a number that we have to calculate in our calculator, and it's a decimal that never ends. So we'll talk about that in our next lesson. But if you take your calculator and do the square root of 10, you're going to get 3 point something. It's going to keep going forever and ever. Okay, those are irrational numbers. When you take the square root of a number, that's not a perfect square. And we learned that at the beginning of our unit on rational numbers. Okay, and then for this last page, if you want, you can pause the video and then just work through this page, and then after check your answers. So 3 squared is 3 times 3, which is 9. So therefore the square root of 9 is 3. 4 squared is 4 times 4, which is 16. So the square root of 16 is 4. 5 squared is 5 times 5, which equals to 25. So the square root of 25 is 5. 6 squared is 6 times 6, which is 36. The square root of 36 is 6. And then moving higher, 7 times 7 is 49. So the square root of 49 is 7. 8 times 8 is 64. So the square root of 64 is 8. And then 9 times 9 is 81. So the square root of 81 is 9. 10 squared is 10 times 10, which is 100. So 100 is a perfect square number. When we take the square root of it, we get 10. 11 squared is 121. When we take the square root of it, we get 11. And then lastly, 12 times 12 is 144. When we take the square root of it, we get 12. Okay, so for today, it's just going over those basic square roots and the understanding of what the answer to square root is and how you can relate it to a square. So the next lesson, we're going to look at square roots of fractions and decimals. Okay, have a great day, guys.